Okay, hello everyone. Welcome back to my YouTube channel, and thank you very much for watching my videos. Today I have a very interesting and very different topic. Okay, I have been invited to deliver a short class about power systems, but this class is mainly created for bachelor students, first year bachelor students. And the idea is to introduce the basic concepts about power systems to attract the students for power engineering. Okay. If you want to download the full document of this class, you can go to my ResearchGate. You are familiar with that. Here is the link, and you can go there and download the full document about this class. And also I will be uploading the slides in a couple weeks time. Okay. Again, some advertising. If you want to follow me on Twitter or LinkedIn, please feel free to do it. More than happy to having you over there. Okay. And let's start. As I say before, this class, the main objective is to deliver a very general introduction to power systems, okay? And also explain the main concepts, the main elements related to power system, okay? The agenda, it's a very short agenda. I will start with a very short introduction about power systems with focus on history. Then I will go for the proper definition of power system and its structure, talking about generation system, transmission system, distribution system. And then I will jump into talking about the basic characteristic that influence the generation and transmission in classical power system. Then a very short summary, closing, and few references, okay, at the very end. Okay, before I start, I would like to say that this presentation is mainly based in this very famous book. It's the Power System book from Weedy and Nick Jenkins and Goran Starbuck and so on. Okay, this is a very famous book. It's mainly with focus in the GB system, and that is the reason that I will be talking so much about the history of the electrical power system in the UK in the GB system. Okay, as you must be familiar, the power systems, the history about power systems started with the very beginning of the power industry. Okay, you must remember in 1882, Thomas Alva Edison started to create the first central generation system in the world, specifically in US, in the New York area, and that was the starting point for the business, the electricity business. Okay, Thomas Alva Edison created a very small plant, generation plant, and the idea was delivering electricity for his customers at the time, mainly for lighting systems. Okay, it was around just 400 lamps, and each one of them consuming around 83 watts. Okay, that is the starting point of the electricity business, the power utilities, and that was in Pearl Street, in Pearl Street Power Station in New York. Okay, but at the same time, that started to happen also almost in 1882, start to be the same situation in GB, in Great Britain. That was the starting point when in London it was installed the first British power plant, and that was the Holborn generating station. Okay, at that time was a very tiny, very small generator, 60 kilowatts, and basically using the steam engine in order to provide 100-volt DC supply for local customers. Okay. Then, Britain started to need more and more electricity, and the first important AC station in Great Britain was Deptford. It was around 10,000 horsepower and producing electricity and delivering 10 kV customers in London. Okay, that was around 1887, and basically was demolished around 1992. Okay. Uh, but from the very beginning, it was a big problem between two important figures, two important persons for the history of electricity. And that was the issue related with Nikola Tesla, George Westinghouse, and Thomas Alva Edison. And it was the relationship between DC current, I mean direct currents and alternate current, okay? Both of them, Thomas Alva Edison, Nikola Tesla, one of them were very, very famous for the advocates of AC and DC, okay? At that time, George Westinghouse and Thomas Alva Edison start to be, let's say, friendly enemies, because one of them was planning to use the AC for the power production, and the other one was planning to use the DC for electrical power distribution. And I will say that very important actors in this battle was Nikola Tesla, because he created all the basic theory behind the AC, okay? However, one key point, and to be honest, the winner point for the AC system, was the development of the transformer. Steinmetz and all his colleagues, they create the transformer, and the transformer makes changes, because at that time the technology, DC technology, was so poor that you cannot increase, you cannot step up the voltages, DC voltages, as easy as AC. The transformer was the breaking point, and from there the electrical power system started to be only AC power system. Okay, in 1927, the Central Electricity Board started to think about that the GB system have more than 400 generating stations, and we have in the GB system high voltage network, and we use the name grid for that network. Okay, and then Britain started to think about creating a stronger infrastructure for electricity, and that was the starting point, the legal point for defining the national gridiron. Okay, that was around 1927, 1928. And that was the starting point for the interconnecting between several generating units inside the GB system, okay? And that was also normalizing voltages and normalizing frequency, and everyone going to 50 hertz, okay? And that was the starting point for what we know today as national grid, okay? The nationalization of the electricity supply in the GB system was legal was starting to be legal in 1947. Okay, the Electricity Act of 1947 start to be in effect on 1948, and the idea was to combine 405 different electricity generation and supply organizations in the GB system, and put the government in charge of them, and the state-owned company will create 14 different areas inside the GB system, creating an authority, the Central Electricity Authority, that takes charge of the planning operation of the electrical system. Okay, and from that act, two important organizations start to be part. One of them was the area boards, mainly on charge of what we know today as distribution and customers, and the generating board on charge of what is today the full generation inside the GB system and the transmission. Okay, the electricity supply industry was publicly owned until 1990. Okay, and it was basically the British electricity supply industry was privatized in 1990. Okay, for the first 80 years of the electricity supply in the GB system was basically a very high growth of electricity consumption, very high, like 7% per year. Okay. um, we must recognize that even in other countries like the USA, this rate was slow compared with the GB system for the first 18 years. Okay. However, today the UK growth is very small. It's probably under 1% per year, but it's not because the load is not increasing. It's also because the effort for increasing the efficiency. I mean, now you are producing more with the same amount of energy. Okay. Um, Okay, what is the important thing that we need to learn from this history? That the secure and reliable and affordable supply of electricity to the customer is the main job that we use, that we have when we are working inside electrical power system. The idea is to produce the low cost electricity as reliable as we can do, and of course in a very secure manner. However, today we have more challenges on the table. One of the challenges is dealing with the CO2 emission in order to mitigate or to reduce the effect of the climate change. Okay, and that is the reason that today the shape of the electrical power system has changed a lot with the introduction of what we call the low carbon sources. That is mainly the integration of resources, energy resources coming from renewable energy, nuclear power plant, and we are trying to avoid any fossil fuel or even any kind of coal. Okay, and the British government have made many efforts in order to reduce the CO2 footprint, and one of those efforts include the use of capture and storage equipment. Okay, but now let's go for business. What is the proper definition of an electrical power system? Okay, the basic definition, it's extremely simple. What you need to know is that an electrical system is a network, electric network, and this electric network is mainly designed to produce electricity, transport the electricity for remote power generation plants into local power stations, and then transform the electricity to some levels that people can use the electricity at home. What I'm trying to say is that a power system is basically an electrical network where we produce electricity, supply that electricity to the customers, but using an infrastructure. And that infrastructure is basically the transmission and distribution infrastructure. Okay. Here you can see a typical sketch of what we call the GB voltage level inside the national grid. Okay, you can see here at the top we have very big power plants, typically located in remote place where we have the resources. Nuclear power plants located far away from the population, for instance, or a hydropower plant located near to the big lakes or dams. And we have a very strong transmission system. Basically, the national grid transmit using very high voltage. In this case, in the GB system, is 400 and 275 kV. Okay. Then the electricity reach near to the population, and we start to reduce the voltage levels, and we use transformers, this very beautiful electrical machine, to reduce the voltage level from 400 to 132, and then almost near inside your town we reduce a bit more the voltage levels, and we arrive to small distribution stations, a small distribution transformer, in order to supply electricity to local industry users. And then we have some other smaller transformer delivering the electricity to 140 volts to your home. Okay, but what is the formal definition of electrical power system? Well, the formal definition of electrical power system can be found in standards or legal documents. Okay, here I will use the IEEE. The IEEE standard 100 say that is basically any kind of electric sources, conductors, and equipment required to supply electric power. Okay, that is one of the definition, IEEE 505. Another definition is the generation resources and or transmission facilities operated as entity to meet load and or interchange commitments, okay? And finally, probably this is one of the my favorite definition, generation resources and or transmission facility operated under common management or supervision to meet load and interchange commitments, okay? That is basically a definition of electrical power system. An electrical power system basically is an electric network that fulfill few activities, few objectives: producing electricity, transporting electricity, distributing the electricity until the customers, okay? For many years, the customer has been just a passive component inside the power system. The situation is changing. A lot of people is installing today a PV system that is a renewable energy resource that is producing electricity. And also some houses, you have some battery energy storage that also help you to, with the PV system, to manage your electricity bill, okay? And for that reason, today we are talking about that the consumption is more active and is changing the role inside the power system, okay? But that is another discussion for another topic. Here I have basically a table that is combining the main functions inside the electrical power system in the context of GP, okay? We have many utilities and many companies doing generation using steam or gas turbines or water like hydropower plants or wind resources, and all of them producing electricity. Example of those companies in the UK context is E.ON, British Energy, and so on, okay? Then we have the transmission, all those overhead lines, all those big cables or pylons or transmission towers working at 275 or 272 kV to 400s and moving the electricity inside the electrical power system. In England and Wales is basically national grid, and for Scotland we have Scottish Power, okay? Then we have the distribution system, mainly very low voltage, 132, 33, 11 kV, and they are basically overhead distribution lines and some underground cables. There are many examples about British utility working as distribution companies, for instance, UK Power Networks, Scottish and South Eastern, and so on, okay? Then we have some suppliers that they purchase energy at the wholesale market and then resell and build electricity. For instance, EDF Energy, E.ON, and British Gas, okay? And finally, we have some consumptions going to motor, heaters, lighting, and supplies for electronic equipments, and that is basically inside the industry, commercial, and domestic customers, okay? Okay, now let me talk just a bit about generation. Generation is basically an electromechanical conversion system. Is taking mechanical power using electrical generators to produce electricity, okay? The generation system can be classified in many ways. One, probably the most convenient way to do it, is basically based on the prime mover that we use to produce the mechanical power, okay? And we can classify those generation systems using that approach, and we can identify, for instance, some generation system using hydro. There are different type of hydro power plants. However, the one typically is the one using a dam and producing electricity from the water, the kinetic energy when we release water from those dams, okay? On the thermal side, we have coal, natural gas, nuclear fuels, and oils, okay? However, you must see that all those they have some environmental impact, okay? Coal, natural gas, oil, they have CO2 emission, nuclear fuel. I will not go there, but all of you must remember Fukushima in Japan, okay? There are another resources. Typically, we call them the non-fossil fuels. And for instance, we can recognize the solar, the wind, the tidal, the geothermal, the biogas as some electricity sources. Okay, and basically, one of the main let's say, characteristic or feature of those generation system is a very low or almost zero CO2 footprints, okay? Hydropower is a very important component of electricity production in some countries. For instance, here in Norway, it's more than 95 to 98% of the generation coming from the hydropower plants, and all of them usually use asynchronous generator for producing electricity. Okay, where we use a different kind of generator is basically in new technologies of generation, like wind turbines, that we can have many other kinds of generators, like the double fed induction machine, square cage induction machines, or permanent magnet induction machines, and so on. Okay, but what you need to know is that generation is typically something that is a very low voltage, 11 to 35 kV in the case of the UK systems, and then we use step-up transformers. You must remember that statements create this transformer and make the changes and key component for the evolution of the AC system, because they allow to modify voltages and current, especially to increase voltages for long distance transmission, volt power, and then we use that high voltage at the local installations to be reduced and then distribute to your houses. Over here you can see they are around 23 kV at generation. Then we go for 400. We move the electricity for several miles. Then we try to reduce, or we reduce to 275. Then we go for substations. High voltage distribution substation going to 132, then 33, then 11, and finally we reach home with 230. Okay. Transmission systems are basically the veins of the electrical power system. Let me forget my medical remark. Transmission systems are basically the wires that they are moving the electricity inside the power system. They are designed mainly for long distances, and the idea is try to reduce as much as we can the active power losses. I mean, what we want to reduce is reducing the heat dissipation by Joule effect on the cables, and for that reason, if we increase a lot the voltage, we are decreasing the current for the same amount of power, and as consequence there are less losses on those cables at high voltage. Okay, and many of those transmission lines, they create some configurations like loops or mesh, and the idea is try to make the system reliable, having different connections for the same point, and in the case of a contingency, we have the possibility of keeping the supply. Okay, the idea is to keep the reliability and the security of the electrical power system as high as we can. Okay, and for that reason, we use high voltages, ultra high voltages, and extra high voltages for transmission. Here in the UK, there in the UK, we use 400 to 275 as usual transmission voltage level, but there are other places. You can go to US or Canada, and you can find voltages of 500 kV or 765. Okay, or even higher, 1100 kV in other places. Some countries, they have an intermediate voltage level that they call subtransmissions, and for the case of the GB system, it's around 66 to 132. They call in some places subtransmission because you can serve some customers, but also you are still moving some volt power. Okay. Here we have the distribution system. The distribution system I call the tail of the power system. Sorry, don't be offended for my remark. Is the very end, is basically the final point of connection before reaching your home. Okay, the distribution level, they are probably the face of the electrical power system to you, and is basically converting and transforming the power supply in order to reach the conditions that you must use at home. Okay, typically the topology, the connection is a single supply, and you have many loads connected to the same supply. That is what we call a radial structure. Is economical, is efficient for some cases, but where there is a problem, if we have a failure on the supply, of course, all the loads connected to the radial feeder will lose the supply, okay? In the case of the GP system, that is between 11 to 33 kV, okay? It's a very small voltage, and that is for the primary distribution voltage, okay? That is the voltage that all the installation connected over there belong to the utility or some big customers, small industry connected to that level, okay? And finally, we have the voltage that is going to the secondary distribution feeders, that they are really connected near to your home, and that is basically between 450, 230, 240 volts and reaching your property, okay? What you need to know is that in normal state, we try to reach your home with a voltage that is inside very strict limits in order to provide electricity with quality requirements and specific limits for voltages, frequencies, and active and reactive power, okay? I am almost near to conclude my presentation, and I must tell you, for many years we have been using AC power for electrical power systems, okay? Of course, DC power has been around for more than a century and has been probably in the last 40, 50 years. It's been a very small part inside the electrical power system. The main component has been AC power systems. And for many years, one of the characteristics of the electrical system, it was similar to the gas and the water. And the electricity is very different to gas and water because we have a problem storing electricity. Right now we have batteries, okay, but those batteries still with a price that is relatively high, and also the energy density is not so high. For that reason, we can say between quote marks, electricity cannot be stored, okay? And for that reason, the balance between generation and demand is a very sensible job inside the electrical power system. And even if we are having some energy storage device, that balance must be carefully controlled and carefully delivered second by second, okay? And that is the job of the generation companies, and the control is basically by the system operator, okay? Something that also we need to realize is that the electricity have a carbon footprint. In the GB system for many years has been a very high CO2 footprint because a lot of coal power plants were working and producing electricity in the GB system. Today we can proudly say that they are a very big component of the electricity that arrives to your home that is coming from renewable energies, mainly photovoltaic system, PV systems, and wind power. However, we have the challenge, and the challenge is deliver the zero CO2 energy electrical power system in the future, okay? And that is a very massive challenge that all of us must work on, get the solution on that, okay? Well, this is the end of part one of my presentation. I would like to close this presentation with a very short summary, and I would like to say that I present here in few slides a very short history history about the electrical utilities with a special focus on the GBCs, the Great Britain system. Then I present a very full a review about what is the definition of electrical power system. It's basically electrical circuits, but this electrical circuit is basically designed to produce power, transport power, distribute the power into the customers. Okay, then we discuss few very briefly but specific about the different components or the main elements in the structure of electrical power system: generation system, transmission system, and distribution system. And finally, we make few reflections, very short but very concise reflections about the characteristic influencing the generation and transmission. I would like to close here. Please, if you are in the GPE, please have a look on the Witty book. It's a classic book for electrical power system, especially if you are going for a very short introduction but very concise. Please go for Witty book, okay? And also, I highly suggest, I love to create my own teaching material, my customized and very well defined for my students teaching material. Please go and go to ResearchGate and go to GitHub and got my teaching material. It's been a pleasure being here with this very short introduction of our power system. I hope that you survive those 25 minutes regarding a short introduction for power systems for non-electrical engineers or very young and just starting to be passionate about electrical power systems. Thank you very much for watching me and see you in the next video. Thanks.